So here's the type of proof that you're likely to see. Again, the difference between this and what we've done before is that the statement that you're looking to prove isn't necessarily directly attainable from the given information. You actually have to go about finding it in an indirect manner. And so I do want to go through and show how that's done. Okay, so let's say we take this diagram and we take the given information that segment AC is the perpendicular bisector of segment BD. So given just that information, you should be able to prove that angle B is congruent to angle D. All right, so if we set up our table, as with all proofs, you're going to start with the given information and just repeat what you have. So we have AC is the perpendicular bisector of BD, and that's the given information. Okay. And all the steps that we do from this are exactly the same as what we've done for the more direct or the simpler proofs, and that is always start with the givens. You're going to kind of work backwards to the end state, which we know has to be angle B and angle D are equal. So in order to prepare the process of reaching that end state, you need to think about what are some ways that you can show angles B and D are equal. For this particular diagram, there's two different ways that you can show it. Okay, one would be if we could show that AD and AB were equal to each other, then we saw in that first section that angles that are opposite equal sides are equal to each other. So we could try to prove it in that way. And in looking at it, there's no way to show that those sides are congruent. There's no information that tells us that. And so consider a second way. The second way is if we could show that the entire set of triangles, ACB and ACD, were congruent to each other, then all the corresponding pieces, which include angle B and angle D, would also be congruent. Okay, so again, you're looking at one of those two ways, and you look to see, can you build your case, which again, that's basically what a proof is. And can you build your case that that is true? Okay, so let's see if we can use one of these patterns to prove that the triangles are congruent, which we could then say the corresponding parts are congruent as well. Right, as with all of the proofs, after you write your given statement, my suggestion is to always start one of two things. Either interpret the given information or introduce the elements of your end state. Okay, so here, angle B and D, we already saw there's nothing really to introduce them other than the fact that they are angles within a triangle. Okay? And since there's no other specific information about that, we'll pass on that. So let's see if we can interpret the given information. What do we know if AC is a perpendicular bisector of BD? There's a couple things that we know. Okay, so one of the things is the portion of the word bisector. So we know that BC is equal to CD by definition of perpendicular bisector. And again, that's the bisect part. Okay, so we know that those two sides are equal to each other. Now there's another part to this definition. What does that other part tell us? Not only are those two pieces BC and CD equal, but yeah, so each of the angles is 90 degrees. So we could also say that because AC is perpendicular to BD, that this angle ACB is equal to 90 degrees. And we can also say that angle ACD is equal to 90 degrees. Okay, so you have one of two ways to use the perpendicular portion of that definition. You can either put it into an equation form in which the angle majors are equal to 90, or you could just write it as a statement relationship, in which case you could also say that angle ACB and ACD are right angles. Okay, either of those work fine. Okay. I'm choosing to go the route of the equation. And the reason for that is so I've interpreted my given statement, and now I can continue to work with what I've introduced here. I have two things, ACB and ACD, that are equal to the same thing, 90 degrees. So what do I know about two things equal to the same thing? They are equal to each other, right? So ACB is equal to measure of angle ACD, because two things equal to the same thing are equal to each other. That is transitive property or substitution. Okay, so here we now have this pair of angles equal. So now when we're looking at the scope of these, finding three elements that fit one of these patterns, we have two elements right now. We have BC and CD, so here's a pair of sides that are equal. We now have a pair of angles that are equal. Okay, so if we look at these patterns to see, can we make any of these work? Well, ASA would require that B and D be equal. Well, if we could prove B and D were equal, we'd be done with our proof. So we're not going to use ASA. AAS, if we could prove this angle up here, angle BAC and angle DAC are equal, then we could say that the whole triangles are congruent. And can we say that those angles are equal because they're opposite equal sides? No, because that relationship only works when it's within the same triangle, in an isosceles triangle. So in these two different triangles, ACB and ACD, that relationship is not necessarily true. Okay? So we're not going to be able to use AAS. And what about SAS? Can we show that AC is equal to AC? Yeah, because it's the same thing, right? So we know that AC is equal to AC. What allows you to make the statement that something is equal to itself? Yeah. Good. So by reflexive property, AC is equal to itself. That gives us a third element, and it fits this pattern, SAS. And now it happens to be written in order of SAS. It's not always going to be the case. And this statement 4 could have been written up here in between statements 1 and 2. The pattern that you use has to do with how the information is arranged on the figure itself, not how it's arranged in the proof. Okay, so by two sides in the included angle, we can now make the statement that the entire triangles are congruent. So triangle ABC is congruent to triangle A corresponds with what point in this other triangle? Also A, it's opposite the two tick marks. B corresponds with D, opposite the side with one tick mark, and C is the right angle, so it corresponds with C. Okay, so the pattern we used, we see up here, was two sides in the included angle, so SAS, gave us congruence of triangles, and once we have triangles congruent, we know that all the corresponding parts of those triangles are also congruent. That includes this part B with this corresponding part D, so we can make our final statement that angle B is congruent to angle D. And the justification for this, again, you can choose one of two things. Specific to triangles is CPCTC. Corresponding parts of congruent triangles are congruent. And then the other more general form of that is, what does anybody recall? Definition of congruence. And we have this congruent statement. We know that that means they're equal in all respects. That includes the corresponding angles B and D.